Welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the Gudgeon pin for transient thermal analysis. We will start by double-clicking on transient thermal. First, we'll go to engineering data. I'll add the material alloy steel. I have to give the value of density. The value is 7700 kg per meter cube, and the value of isotropic thermal conductivity is 45 watt per meter Kelvin. So these two values are to be added. Next, I'll go to project and I'll update project. Then I'll go to geometry and right click. Import geometry of piston pin. Then I'll go to model and double click on it. First, I'll go to geometry and change the material. I'll allocate the material, that is alloy steel. Then I'll go to mesh and change the sizing to fine and update. I'll now go to transient thermal analysis settings. I will give number of steps as 20. I'll change auto time stepping to on. Initial time step I'll give as 0.01. Minimum time step I'll leave it to 0.001. And maximum time step I'll leave it to 0.1 seconds. Then I'll go to transient thermal and insert temperature on this surface. As you are aware that this piston pin will have a maximum temperature of 250 to 300 degrees Celsius. So I will give the maximum temperature over here as 300. The rest of the values will be self-entered. Only I have to change this value. The first one, say it is 30. So accordingly all the values get added. Also I am going to insert convection on the inner surfaces, which will help lose the heat. Apply. I will change the film coefficient over here and I will give import temperature dependent. I'll choose the first option, stagnant air horizontal cylinder. Okay. Ambient temperature I'll change it to 80 degrees Celsius. Now we are doing the analysis for time dependent analysis, wherein you will lose heat over a period of time on the piston pin. So you have to be careful while giving the values of temperature and convection. They should be values which are changing with respect to a particular factor, say temperature. If you observe the analysis which we have done before this of steady state thermal analysis, there the temperature was fixed and so was the value of convection coefficient. So accordingly here you are just changing the values with respect to temperature, which you have not done in the previous analysis. This is how you differentiate between the two analyses of steady state thermal and transient thermal. Steady state thermal means your time is constant, or rather I would say the factors do not change with respect to time. Here your time is going to affect the value of temperature over the body. So once this is done, I will go to solution and insert thermal temperature. Also I will insert thermal total heat flux. If you observe, we are doing the same result analysis for both of them, but the pattern of analysis is different. So I'll go to solution now and solve. There is another difference between steady state thermal and transient thermal analysis. That is the time taken for obtaining the solution. For steady state thermal, it takes not more than 30 seconds to a minute to complete the solution. But when you come to transient thermal, it takes a real good amount of time. You can see here the elapsed time is 5 minutes 29 seconds. It is quite a long duration. First, we'll go to temperature. Here you can see the value of temperature variation over the body. You can see a graph of temperature variation from 0 to 20 steps that we had taken, and these are the values of temperature for each step that you have given. You have given a value of 0.01 as the minimum step. That is the difference between the two readings that you obtain here, and that's how you get a variety of temperatures for these 20 steps. Next, you can go to total heat flux. Here you can see there are two graphs. One is the minimum heat flux that you see, and one is the major value. To the right, you can see here there are two tables. If you tick on the red one, what remains is the maximum heat transfer over the body at a particular instant of time. You can see here there's a column of time and heat flux. So for a particular time, a particular heat flux can be seen, and this will be counted up to 20 seconds. So that is the number of steps that you have given. And here you get an average value of maximum heat flux, that is 0.0038605 watt per mm square, which is over the entire body. And the minimum value is 0.0012918 watt per mm square. This is the graph of maximum heat flux, and if you tick here and untick the green one, you will see a minimum heat flux graph. You can see the units is watt per mm square. So heat flux varying with respect to time. As on the x-axis, here you have time. So that's what you can get here. You can animate and see the result of heat flux. Also, you can animate and check for the temperature. You can see here the temperature variation. Maximum value is 300 that we had given, and the minimum value here is 22.08 over the entire body. That's because here you have given minimum value is 22. So that's how you come down to this temperature. So when you animate, you can see there's various temperatures over the body. So with this, I end the session. I hope you have understood the transient thermal analysis of a Gudgeon pin. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.